My name is Andrea Segarra, and in this video I will present project number 3, shortest path routing for the course Computer Networks. The objective of this project is to investigate the shortest path routing problem and implement a routing algorithm in Python using Jupyter Notebook. For this project, I selected the short algorithm because it is efficient for weighted graphs with non-negative edge cost, which matches the network used in this project. I first started by importing the required libraries. I used heap-q to implement the priority queue, network X to create and visualize the graph, and matplotlib to display the network topology. Next, I defined the graph class. This class stores a network using an adjacency list, where each node has a list of neighboring nodes and the cost to reach them. Inside the class, I implemented the disgraph function. This function starts by setting the distance from the source node to 0 and all other distances to infinity. Then it uses a priority queue to always select the node with the smallest current distance. For each node, the algorithm checks if its neighbors and calculates a new possible distance. If this new distance is smaller than the current stored distance, the algorithm updates the distance and stores the previous node. This allows the program to later reconstruct the shortest path. The reconstruct path function is used after the disgraph function finishes. It starts at the destination node and traces backward using the previous node information until it reaches the source node. Then the path is reversed so it can be displayed from the source to destination. After defining the algorithm, I created the network topology using an adjacency list. Each key represents a node, such as YA, CA1, and so on. And each value contains the connected neighbors and edge weights. Then, I created the graph object, test case section, and tested the 3 required source destination pairs. The output shows the shortest path for each case and the total cost. For example, for NY to CA2, the algorithm returns the path NY to DC, to Texas, to Colorado, to California, with a total cost of $3,900. After verifying the output, I used network X to visualize the graph. The node represents the location in the network and edges to represent connections, and the number on the edges and the number of the edges represent the routing costs. Finally, I highlighted one shortest path in red to show how the selected route appears in the network topology. This helps visualize visually to confirm the path selected by the disgraph algorithm. In conclusion, the implementation successfully computes the shortest routing path for the required test cases. Disgraph algorithm was appropriate for this project because the graph uses non-negative edge weights, and the priority queue implementation makes the algorithm efficient for the shortest path routing problems. Thank you very much.